Hey everyone, so welcome back to my channel again, Intelligent Learners. This video is about the introduction of straight lines, right? Straight line is the part of coordinate geometry. So we have very little discussion about the coordinate geometry. What is the coordinate geometry? What all we have in the coordinate geometry? Just an introduction. Then for the straight line, we know that line is made up of points, right? Other than straight line, we have the curved line. So difference between the straight line and the curved line, and we know that lines are made up of points. So little discussion about the point. What is a point? And when we have point in the Cartesian system, right, in the quadrant system, then what is the Cartesian system? What all we have in the quadrant system, that about the quadrants, about the sign convention of the points in different quadrants that we have. Then the formation, the form of the Cartesian coordinates. So when we are writing the coordinates, so there may be a possibility that we can write in the Cartesian form, like as the ordered pair of real numbers, or we can write the coordinates in the polar form. Okay, so for the polar form, we have to find out the modulus or the displacement, and we should know the argument, which is the theta angle. Okay, that is have with the positive x-axis. So this all we are going to discuss in the video. So yeah, let's start with the video, everyone.
Straight lines. Straight lines is the part of coordinate geometry. Okay. Straight line is the part of coordinate geometry. So before moving towards the straight line, we should know little about the coordinate geometry, right? What is a coordinate geometry actually? It's a branch of mathematics, okay, where we are learning about the lines, right? And where we are learning about the figures, okay? So before line, we have an object which is called as the point, okay, which is called as the point. What is a point? Point is an object which is dimensionless, means there is no length, width, or height of a point. So point is dimensionless, okay? Then if we will join so many points together, okay, either in a straight path or going through any path, suppose we have these points, and if I will add like this, or if I have 3 points like this, if I will add like this, or if I have these 3 points, I can add like this. Okay, so when I join the points, when I have the points and I join them, so I got some lines. Okay, now lines are of two types. One is a curved line, okay, and second one we have is the straight line. Okay, we will discuss that. Next, with the help of the line segments, we make some figures which are 2D shapes, like we have rectangle, we have squares, we have rhombus, kite, parallelogram, trapezium, and all that. We have 3D shapes also, okay, in which we are adding the height dimension, right? So we have the 3D shapes also, like we have cube, cuboid, cylinder, cone, and all that. So everything that we have here, point, lines, figures, they all are the part of coordinate geometry. Means we learn them with the help of the coordinates, or we can say that we learn them with the help of the graphs, right? Okay, now let's have a discussion further. So coordinate geometry is what? It's a branch of mathematics which include the study of the different curves, okay, like lines and figures by ordered pair of real numbers. Means with the help of the coordinates that we will learn. Coordinates we will understand later. Representing lines and curve by algebraic equation, means coordinate geometry means we are talking about the lines, we are talking about the figures with the help of the algebraic equation. Means algebraic equation or algebraic expression means what? Means we are using some variables to write the equation of the straight line. We are using some variables, we are adding them, subtracting something, multiplying something. So that is all algebra, okay? So geometry plus algebra gives the coordinate geometry, right? Okay, now let's have a discussion about what is the difference between the straight line and the curved line, okay? Now if you will see, if I have 2 points, one is point A and one is point D, correct? If I choose to move from A to D, from A to D, if I choose this path like this, so this path is the curved path. It's very clear from the visual representation that yes, it's a curved path, okay? It's curvilinear. So if you will see, this is the total path I carried to move from A to D. So this path is called as the distance. This total length of this path is called as the distance. But if I chose to move from A to D, like the shortest distance is this one, without moving here, here, I just got this path, okay, like from here to here, straight path. So this is the displacement. Displacement means the shortest path from one position to another position. So here, if you will see, the distance is more than the displacement. So when the distance is more than the displacement, so that line is called as the curved line. Okay, curved line in which the distance is more than the displacement. But if suppose this is point A and this is point D, and if I just choose this path, the straight path, okay, without moving here, there, so here the distance and the displacement both are same. So when the distance is equals to displacement, then we can say that it is a straight line. Okay, it is a straight line, right? It's clear, it's a straight line. So this is the difference between the straight line and the curved line. Okay, so understand this one. This is from A to D and this is from A towards D. Towards D. It's very, very important, right? So this is the difference between the curved line and the straight line. So I think it's very much clear to you. Now let's have a discussion about the coordinates first. So if you will see the coordinates, you know that Cartesian system, quadrant system. Cartesian system, when we are talking about the Cartesian system, so let's talk about 2D geometry first, okay? Let's talk about the 2D part right now. So we know that we have, when we are talking about the Cartesian system, so we have, just a second, what happened? Okay. If I'm drawing this line, you know that this is a number line. Okay, this is a number line where in the middle we have 0. In the right side, we have the positive numbers, means we are going forward. And in the left side, we are having the negative numbers like 1, 2, 3, 1, 2, 3, 4, and so on. And in the left side, we have -1, -2, -3, -4, -5, and so on, right? So we can call this horizontal line or this horizontal line as the x-axis, okay? In the right side, we have the positive values of x, and in the left side, we have the negative values of x. It is not there that we have the negative and the positive values. Negative and positive, we are just using for our convenience. Negative and positive means either we are increasing the steps or we are decreasing the steps. So we are, for the decrement, we are using the negative signs, correct? So this is, we called as the real axis also. We can call it as the horizontal axis also. And we can also call it as the x-axis also. Okay, the 3 names we have, correct? So whatever the numbers you have on x-axis or the real axis or the horizontal axis, we can call those numbers. So whatever we have as x, that we called as the abscissa. Okay, abscissa we can call it. ABSCISSA, abscissa. Okay, x part is called as the abscissa. Now we know that we have y part also. We have y part also, which is perpendicular to x-axis crossing through origin, which is 0. So this is y-axis, which is a vertical line, okay, which is a vertical line, and it is perpendicular to, perpendicular means making an angle of 90 degrees with each other, okay, x-axis and y-axis. So this is the y-axis. Above values show you that you are increasing the steps, and below value, they are saying that you are decreasing the steps like that. So this is y dash, this is y, and this is o. So whatever you have on the y portion, negative, positive, so we called as the ordinate. We can call it as the ordinate. So together, x comma y, when we are talking about the 2D geometry, because 2D geometry means 2-dimensional, where we are using x and y axis only. So these total we called as the coordinates. Okay, total we called as the coordinates, or we can call it as the lattice point also together. But please remember, first we will write the real part, and then we are taking the y-axis. Okay, the imaginary part. We can also call it as the imaginary part. Please remember that whenever we have two axes, it is not necessary that always they have a 90-degree angle, means always they are perpendicular. No, they can be oblique also, like this. Okay, the angle could be anything. So Angle could be anything. There may be two axes, may be parallel, maybe perpendicular, maybe they will be oblique. Okay, they have some different angle, less than 90 or greater than 90, like that, right? Okay, so this is the coordinate. Now, I think up till here, this is clear. Now, when we are talking about the 3D geometry, when we are talking about the 3D geometry in which we are adding one more axis, which is the z-axis, right? Which is the z-axis. So that z-axis, which we are taking here, like here. So that z-axis is called as the applicate, okay? The z point that we called as the applicate, okay? The z coordinate is called as the applicate, right? Now, a very interesting thing that you have to understand is the point of origin. So where all the axes meet, that point is called as the point of origin, point of origin. And the coordinate means this coordinate of the point origin is called as 0, 0. It's very important to understand. So this is the point where the distance of that point from x-axis and distance from the distance of a point from y-axis 0, again 0, 0. So that's why the coordinate is 0, 0, right? So this is the thing. So I think oblique axis is very much clear. When the angle between the two axes, they are not equals to 90 degree, it is either less than or it is greater than 90 degree. So that is the oblique axis. Okay, I think it's clear. Now let's have a discussion more about the points. Suppose this is the quadrant system. First talk about the quadrants. We know that what is a quadrant? What's the meaning of quadrant? Quadrant means when we have something as a plane thing and we are dividing that plane thing into 4 equal parts, then every portion is called as the quadrant, means the 1/4. Okay, 1/4 portion. So this portion is 90 degree, this portion is 90 degree, this portion is 90 degree, and this portion is also 90 degree. Okay, so every portion is called as the quadrant. It is the 1/4 part of the total, correct? So quadrant means this one, right? 1/4 part. Now, please remember, if we will see this is the first quadrant, this is not second, this one is the second one, then we are moving third one, then we are fourth one. Means we are moving anti-clockwise. Anti-clockwise. Anti-clockwise means what? Please understand, whenever we are talking about the angles on the Cartesian system or the coordinate plane, this is the 0 degree. We are always start measuring the angle from 0 degree. Okay. So when we are, this is the 0, we know that when we are going up, this is 90 because this is making an angle of 90. This is also 90. But when we are going clockwise, we are taking the negative angles. Angles are also negative also. That we will discuss later. So this is 0. This is 90. Then again 90 plus 180. Then again 90 plus 270 and 360 and so on. It goes on. So that's why we are taking this quadrant at first, second, third, and fourth. Okay. It's clear. Now, please understand one more thing. What are the conventions, sign convention for different quadrants? Okay. If you will see the first quadrant from this line and this line. So this portion of the x-axis, the positive values, and also this portion of the y-axis of the positive y. Upper portion of y is positive. So both are positive. So that's why plus plus. Similarly, if you will see the next quadrant, the second quadrant from this line, which is the left part of the x-axis. So x is negative, and this is the upper part of the y, which is positive. So that's why plus, minus, plus. Then we have both minus, minus, and then we have plus, minus. Now, please remember, it is not necessary that between the two coordinates, you should write the comma. But just for our convenience, we write the commas between the 2 points. Okay. Now, what is the meaning of x and y? Let's talk about the point. Okay. Point in any quadrant system, right? Let's talk about the point. So let's say it is not straight, but this is a quadrant system. Let's see. This is the origin. Okay. This is x-axis, negative x, positive y, negative y, right? Let's take a point in the first quadrant. Let's take this point in the first quadrant. Okay. Let's say 1, 2, 3, 4, 5, and 1, 2, 3, 4. Let's. Okay. If I will see this point, what is x and y actually? Okay. So if I will see what is x, x is, so if you will see on the x-axis, how much distance it is covering, because it is covering this distance to reach A from origin. It starts from here, then it reaches here. Let's say this point is B, and then from B, it goes here. Okay. So what is x? X is the distance of this point from the y-axis. Why y-axis? When we are talking about x, so why the distance is from the y. So if you will see how much distance it is going from here to here, O to B. That 1 step, 2 step, 3 step, 4 step, 5 step. So this is 5. Similarly, from B to A, how much step it is going? 1, 2, 3, 4, because they both are parallel. So this is also 4. From B to A, it is covering 4 units. So if you will see the distance of point A from Y, because this line is parallel to this one and they both are equal because they are making square. So this is 5, this is also 5. If you will see this point A, distance from Y axis is 5. So please, when we are writing the X coordinate, is it the distance of a point from Y axis? Okay, please remember this thing very carefully. But if I will see the point distance from x-axis, so this is x-axis is here and the point is here. So we are talking about this distance. So what is the distance it is? It is 4. Okay, so it is from the x-axis. Please remember, 5 is the distance of a point A from what? From y-axis, and x4 is the distance of a point from x-axis. Okay, please remember this thing. And always we are writing x first and y later. Okay, the real part first, and then we have on the y-axis we have the imaginary part. So this is the thing that is very, very important. You have to understand in all coordinates, it is please exactly the same. Okay, x coordinate means distance from the y-axis. Y coordinate means distance of a point from x-axis. Please remember. Okay, now let's have a discussion about the polar coordinates, which is very, very important. So polar coordinates, right? Okay, polar coordinates. So like we have the Cartesian coordinates where we are writing the ordered pair of real numbers like 2, 3, like we are minus 2, minus 3, or 2, minus 3, or 3, minus 2, like that. So these are the Cartesian coordinates where we are writing the real numbers as the ordered pair. But in the polar coordinates, we are taking the displacement and we are taking the angle. Okay, now what is the meaning of, see what is the coordinates, sorry, coordinates, polar coordinates. What are these actually? So if I will draw the quadrant system, both the axes are at 90 degrees to each other. This is the x-axis, negative x, positive y, negative y, and this is the point of origin. Okay, now if you will see, let's say the point is here. Okay, I don't know how much distance it is covering from this point to this point, let's to B point. So I am taking this portion, let's say as x. Okay, I don't know, or x1 or whatever you want to take. And suppose I am taking from B to A, I am covering this much distance, let's say on y, because it is parallel to this portion and it is the y-axis, right? So if I will join AO to A, so this is the displacement. See, I have the option either to go, this way and then this way to reach A from origin. And if I have the option, I will choose the shortest path. So this is the shortest path, and shortest path we are representing by small r. Okay, displacement basically. So polar coordinates, we show it like in the Cartesian coordinates, we show as x, y. So the polar coordinates we represent as r, theta. Now r, we have understood r is the displacement, or r is called as the modulus also. Okay, r is the displacement, or we can call it as the modulus also. What is theta? That this portion, this line segment is making what angle with the positive x-axis? Okay, that is theta. That is the argument. Okay, so this we can call it as the modulus or the displacement. And this one is called as the argument. Okay, argument. Clear? Now, what are the values of this? If you will see, if I will apply cos theta in this triangle, because it is a right angle triangle, AB is perpendicular on the x-axis, cos theta, which is the, what is the formula for cos theta? That is the adjacent side over the hypotenuse. So in this right triangle, according to this theta, what is the adjacent side? X. Okay, and what is the hypotenuse? R. So what is the value of x coming? So x is r cos theta. Okay, if I will apply the sine theta, so sine theta we know that, which is the opposite side over hypotenuse. What is the opposite side? Opposite side is y and the hypotenuse is r. So y is equals to r sine theta. Clear? So x value is this one. So, or we can write the Cartesian coordinates. If you want to write, you can write as P of r cos theta, comma r sine theta. Okay. So this is the formation of the Cartesian coordinates, either this way or this way. And or the polar coordinates can be represented at P of r comma theta. So what is r? The displacement. Now let's talk about the theta. So theta is, if I will apply the tan theta that is equals to the perpendicular, that is the opposite side over the adjacent side. So what is P? It's Y. And what is this? This is this. So tan theta is equals to Y over X. And if we will say tan as to the right hand side, it will become theta is equals to tan inverse Y over X. So this is the value of theta. Okay, this is the value of theta. And what is the value of R? Please remember, what is the value of R? R, if I will apply the Pythagoras theorem in this right angle triangle. So what is the Pythagoras theorem says? So I'll change the color. Okay, if I will apply the Pythagoras theorem, so Pythagoras theorem says hypotenuse square is equals to the opposite side square plus adjacent side square. So hypotenuse is what? This is the hypotenuse because the front side of the 90-degree angle, which is R square, opposite side, which is this one, Y, and adjacent side is X. So this is this according to this angle theta. So what is R? R is equals to square root of Y square plus X square. So this is the value of R. Okay. So theta is tan inverse Y over X. R is equals to under root Y square plus X square. That's that, everyone. Thank you.